So welcome everybody to Masterclass number 9. Hard to believe, but here we are. Today's Masterclass is going to be on IoT for smart places. My name is Rory Brown. I'm the director in the Smart Places team in the New South Wales Department of Planning, Industry and Environment, and it's my great privilege to be facilitating today's Masterclass. Before we get going, I did want to acknowledge country. I'm speaking to you today from the land of the Camaragal people of the Gurungai tribe of the Eora Nation. And I'd like to acknowledge the traditional co-custodians of the various lands on which we are all virtually meeting today. I'd like to pay my respects to elders past, present, and emerging, and also extend that respect to other Indigenous Australians who are joining us today. Before we really get into the content, there's a couple of housekeeping rules that I want to go through with you. I think everyone's well versed on this, and I can see we're all adapting to it already, but just want to remind you all, I can ask you to remain on mute. We do have the chat going today, so if you have questions, please post them in the chat. And you will have seen a note that this evening's event is being recorded, and we'll let you know where to access that at the end of this, the conclusion of this session. So with that, why are we all here? Well, today we are going to be learning more about IoT for smart places. I am really pleased to be joined by 3 leaders in this space. We've got Frank Zeichner, who's the CEO of the Internet of Things Alliance Australia. We've got Professor Pascal Perez, the Director of the Smart Infrastructure Facility at the University of Wollongong. And we've got Kim Yan, who's the Chair of Standards Australia Committee, IoT 042 Internet of Things and Related Technologies. Also a Senior Corporate Compliance Engineer at Cisco Systems. So what's going to happen today is each of our panelists are going to give an overview from their perspective of what's going on with respect to IoT and smart places. We're going to start big. We're going to hear about what's the sort of the latest insights, think about sort of the state of the nation, not quite yet, so I know that's coming up. But a little bit in the maturity levels. We'll also then dive in, learn what's happening on the practical perspective when we start to deploy. What are some of those key learnings about using IoT and smart places, smart cities, and then we'll close with a view in the standards and start to think about how we can ultimately make that easier for the future. So please do hold on. It's going to be a great couple of hours. There'll be plenty of time for questions and discussions with everyone today. I'm looking forward to it. Now, so with that, I would like to introduce our first speaker, and that's going to be Frank. A little bit more about Frank. He's a thought leader in the adoption of Internet of Things, and indeed in Australia is the founder and CEO of the IoT Alliance, which is the peak Australian Internet of Things industry body. And their mission is to drive Australia's competitiveness and societal benefit through collaboration across the research industry, government and community. Frank's also partner manager for the Race 2030 CRC. That's the Reliable, Affordable, Clean Energy for 2030 Cooperative Research Centre. It's an industry-led research effort to drive energy innovation across the supply chain to deliver better value for energy customers. On top of that, he's also an industry board member for the New South Wales Smart Sensing Network, and that brings together smart sensing expertise in academia, industry, and governance to develop a strong, collaborative, and innovation network that will deliver economic and social benefits for New South Wales. So it is with my great pleasure to hand over to Frank to kick us off. Thank you.
Thank you very much, Rory, and pleased to be here and welcome all those on the call. I'm just going to turn my presentation on, and I think that's it. So welcome, and let me start off by introducing you to the IoT Alliance. Some of you may not know who we are. We are the peak IoT industry body, and our vision is to accelerate the adoption of IoT in Australia to improve our competitive advantage and benefit society. Why is that important? Because the onset of Internet of Things technology is happening everywhere globally, and the ability for us to take it on board in an Australian way that suits our culture, that suits our privacy and ethical culture is really, really important for us to adopt it well, and also to take leadership. And that needs conversation, it needs collaboration, and it's not something that you adopt by default. That's the thing that I fear and that we fear the most, that we'll just wait for it to descend upon us, in which case we're not in charge of our own destiny. Our focus is to nurture and build the IoT ecosystem, and to catalyze sector and technology sector tech industry. So that happens within verticals. So it happens within smart cities. It happens within energy, transport, etc. We are strongly advocating in areas that matter around policy and regulation in IoT, and that will help us unlock that innovation. We really believe in learning by doing and practicing. IoT is, and I explained a little bit about what it actually is one of those things that you sort of need to experience a little bit to really understand the advantages and the impact, and it needs an understanding of how purpose aligns with the data that you need to drive that purpose. It's a different way of thinking, and ultimately we also care about the trust that we need to build, and that IoT should be ultimately for the good of society and for all of us. And so being secure is one thing, but also building a better world and being cognizant of the sustainability development goals is something in our ethos.
Frank, can I just ask you to flick your camera on? We can see your slides, we just can't see you.
Oh, why can't you see me? My camera is on.
That's right, then keep going, we'll press it through.
Sorry about that. Not sure. Okay. Firstly, is it working?
Must be at my end, Frank. Yes, we can. I've got a few people saying we can see, so please continue on.
Okay, no worries. So let me start with a definition of IoT, and as many people as write about it have an opinion on it, but I always go back to the international standards, which matter the most because that's the bedrock upon which it all hinges, and I'm sure that Kim will agree with that. It is an infrastructure of interconnected objects, people, systems, and information resources together with intelligent services to allow them to process information of the physical and virtual world and react. So it is a complete system, end to end. It matches physical to virtual, does smart things in the virtual world, and then goes back to the physical world. It's a complete end-to-end system. It is not only sensors. It is that whole end-to-end system. It incorporates intelligence. It incorporates data management. It incorporates the sensors and incorporates the networks. So how they work in concert to deliver the data you need when you need it with the authenticity and validity that you need, that is the key. We've in IoT Alliance have created a rubric through which we can see these things, which is our a reference framework. But I won't go through that with you today. But ultimately, you should understand that it's multi-technology and it is always cross-sectoral. Data knows no boundaries. The data that we collect for temperature, which may be relevant to the operation of a machine, may also be relevant to the safe working environment for individuals or a whole lot of other reasons. So data can be used for multiple purposes, and the availability and discovery of that data is part of the value that we can unlock if we understand how to do that. We're structured across 7 verticals and a number of IoT technology enablers. So the whole point of IoT is about making things real, making things real in food and ag through better precision farming, through better use of water, in the water industry, through circular economy on how we use water and how we use water in the home, the energy use of water to optimize it. In transport, it's about supply chain. It's about delivering good quality. It's about delivering the value along with the goods and having that attached, the data about the value, i.e. is it is it grown in a safe environment? Is it transported safely to add to the value of the final cell in the product? It's about manufacturing productivity. It's about new innovation in understanding how the design works by understanding the data you're using. And it's about health, and we've seen plenty of examples of that. Nobody knew what a QR code was really about 2 years ago, but now pretty much everybody does. So it is all about that transformation side of it. It's all about making data real. That's what IoT is, making data real. But underneath, common to all of these sectors, and that's not all the sectors, of course, are the enabling technologies and environment. We've got groups on IoT interoperability, on security, and on data use and availability, as well as with startups, and we look at the skills that are needed. So it's a matrix to make it work, but the rules for how the technology works are applied differently in different sectors, because different sectors have different trust circles, different legacy suppliers, different legacy practices, and cracking through the understanding of what's needed, not limited by the way it was done before, is part of the magic of unlocking the value of IoT. So let me move into smart cities. That was sort of my introduction about where I'm coming from. This chart is sort of probably like the Uber chart, possibly for Kim in the standards group. But this is also a chart that applies both to cities as it applies to IoT in general. And it's from the International Standards Organization 37106 standard. And it's about how the operating model will change, or should change, or needs to change for a true smart city. And this is how IoT affects it. So you'll see in here a whole lot of vertical lines that are purple: energy, waste, water, telecoms, policing, and education, transport, health. These are all vertical areas of and domains that are in cities and places. They are traditionally all managed by their own operational teams, often by their own technologies, have their own data sets, hopefully don't collect the same customer data every time, but some do. And this is the way that cities tend to operate. And the data sets that are relevant to each of these pretty much siloed within those verticals. And in some of those, of course, a city, for example, doesn't have much access to energy data about consumers, but might actually find that useful in some circumstances. For example, if they wanted to build a community battery for a city, for a council in a rural area, and share and possibly back up a battery for solar generation by citizens. A whole lot of different interesting models where that sort of data becomes interesting. So a smart city is one that starts understanding and leveraging the assets, digital assets, and the data that's collected across all of these verticals, and ultimately has that data accessible so that you can apply intelligence, business management, service management to deliver new things. So this is the nirvana. In practice, it's easy to picture, but it's very, very hard to do because of existing practices and whole other things. This is the goal. And ultimately, I put this little thing on the side, which isn't part of the standards, this thing called digital twin. which I find a very useful tool to sort of imagine where the data could go so that you could reuse it for multiple purposes. We're in very early days for that, but and Kim will say a little bit more about digital twin later on. But to try and give you something useful in the next 10 or 15 minutes, I've got 3 or 4 slides which look at that journey from vertical to horizontal and how we perceive the cities are going down that track. IoT Alliance has a Smart Cities workstream, as you would have seen. We've also and our members have been involved in many smart city projects. We see them going on, and in a general set of buckets that we've created, we sort of see the evolution of cities in sort of 4 phases. Phase 1 is cities using IoT to improve productivity within an existing business model, i.e., improve parking or a better cycle of rubbish collection, or a more automated way of looking at environmental parameters rather than just measuring them in a manual way, just to improve their processes. Now that's happening. It's happening to a lot of places, and I'll mention it a little bit more later. But they're all pretty much within their existing business model, and they're almost always independent to the normal operation of how a council works today. So in other words, it's a trial. Phase 2 is when the data from a number of these vertical trials start becoming shared, where we're federating the data, where we're starting to build that platform of horizontal data sets that we can start reusing in multiple ways. Phase 3, we get to the point where that data is now both longitudinal enough and authenticated and valid enough so that machine learning and AI can start becoming really useful. This is sort of beyond the level of thresholding, but now at the level of where insights start happening. And that only really happens when you've got reliable, longer-term data sets that allow you to start planning and to start recognizing patterns. This is a promise of what is to come, and we keep saying there's so much promise in here. Let me give you an example. There's an Australian company called Rosetta in the finance industry that for years was collecting tapes in those days from Reuters on stock market activities. And those tapes were sent by Reuters to them because I thought, well, it's all old information. People only care about what's actually happening now. And Rosetta, which was a group of researchers, started looking at that data, that old data, and started noticing things, behaviors, patterns, trigger points that were automated and caused automatic bidding and a whole lot of other really interesting behaviors and compliance issues. And now they sell that service to 600 stock exchanges, including the Federal Reserve. And that's all old data. But that old data told them a lot about how the place worked and how it operated in real time. So this is the promise for cities. And then ultimately we get to this thing called digital twin, where you're not only seeing insights into the way you're doing business, but you're now predicting and understanding how you work inside and outside a city. That's really sophisticated. No one's there, really. This is mostly anecdotal, but we've done a study just recently across 27 city councils who have actually undergoing smart city programs. I'm not going to steal all the thunder of that. I've got one slide on it, but some of the information here comes from that as well. So in phase 1, people doing IoT to improve productivity, they overlap a lot with the cities that received the federal Smart City Grant program, about 80 or so city councils. Many of them doing IoT projects are in more than one domain. So And those common ones are environmental monitoring, people counting, asset utilization, parking, etc. So they're all learning and they're all learning some of the common mistakes that I know I learned because I was at UTS doing 3 of them. And Pascal will talk about some of those problems. I'm not going to go down that track. It's a rich path. They're pretty much all characterized by LoRaWAN type networks, which are low bandwidth wide area network ones, which are both private and public. Most of them are private ones where the councils are buying their own network equipment. So they're taking the capital cost, which is pretty low, and there's no on usage costs. All of them also most of them have elements of Wi-Fi and 4G in it as well. And the characteristics of those networks give you different possibilities in terms of what you can actually do with that data. What's happened here? Why is that? Okay. Okay. Some of them use a bit of, there's a bit of low cost data storage. So there's a little bit of stovepiped collection of that data. Most of it's actually connected with, is collected by the dashboard providers, actually. So the data is not actually connected in a lake or anything that looks like a lake. Tends to be stored in a sort of a one size fits all sort of dashboard database type package, which is fine for single use. Not so good if you want to share that data across different dashboards and indeed across different services and different networks, different departments. And an absolute huge range of sensors out there. And the one thing that we all learned is that local support really, 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 really matters. Doesn't matter how good it looks on paper, if it's not supported locally, turnaround time at fixing these things is ridiculous. So all of those ones in phase 1 are demonstrated widespread access to network deployment, and they're collecting data, which is great. There are a number that are sort of migrating into phase 2, which is this federation of data. That also is identified by those who start incorporating external data sources. So not only collecting their own data from their own sensors via their own networks, but also looking at other data sources that can correspond with those, like Fitbit or battery hydraulics lab information, for example, on tidal flows, which was used by Lake Macquarie and Northern Beaches for Smart Beaches, a program that they did. I'm sorry that my screen keeps going weird on me, so I've got to keep popping back to what I'm looking at. Okay. Where's my? Okay. Also, Transport for New South Wales information. There's some analytics at this level, but little or no AI or ML, because frankly the data sets aren't long enough. They're not reliable enough. They've got gaps in them, and there's a lot of work to be done on cleaning the data to make sure that it's good quality across the board, and to fill in the gaps where the sensors turn off and on and everything else. So that data management side of it is still relatively primitive, and they're mostly pilots and not really scaled. So I've got pilots are scaling, they're trying to, but the business case for investing in the data infrastructure to get to maturity level 2, a real maturity level 2, needs help. And indeed, the making it real business case is part of the problem of that, and that's possibly also a case of you need to share it across more than one stovepipe to justify it. If we move to stages 3 and 4, there's less on here because frankly there's less that are at this level. Phase 3 is where I should have made the point that at phase 2 and in phase 1, most of the data and the visualization of the data is internal. Very, very restricted amount of data goes out to an open portal that's for the community for a whole lot of reasons. Part of it's because it's a bit unreliable, but it's also because there are some security and privacy issues, and there's an education program also that should come along with that, so that people understand what they're seeing. When we get to phase 3, this is when the data infrastructure is in place so that you know that it's good quality, you know that it's continual, you have methods and mechanisms for cleaning the data, for ingesting multiple data sources, and for then applying machine learning and AI. There are some cases of that happening in some very small verticals, but I can tell you that my experience of what I've seen is those who are applying the AI and ML spend 90% of their time cleaning the data before it's useful. So the cleaning the data is number one before any of the other fancy stuff becomes useful. The purpose for doing this is this requires IT and OT to work together. Why are we doing it? How does it actually affect workflow is when it really comes into its own. Herein lies the sort of evolution that we are sort of requiring here. It's great getting the data, but having people having to sit there and then react is not good. It's building it into workflow is really important. And that's the stage at where the reason for doing it becomes important. And so my observation is where the work has really got to be done, where the operational hits the IT, and indeed where the IT starts recognizing their role in supporting that IoT implementation, still sitting on the side. Finally, this nirvana called digital twin. This is an interesting thing where we have a spatial, visual, real-time view that's also longitudinal that gives us ability to predict and have a look what's going on. We're a long way away from that, but thankfully there are platforms that are starting to help us. We had a great presentation a few days ago from Wayne Patterson from the New South Wales Spatial Group, and their supporting of digital twin initiatives and sharing of data across multiple platforms. They're providing some of that common platform, common data source facility that can be dipped into. And I suspect that whatever happens in the future with smart cities on phase 4, that federated partnering model is going to be part of it. And perhaps in New South Wales Spatial Service will be part of that digital twin. And finally, one last slide from our benchmarking. So the IT Alliance and Smart Cities Council have now kicked off an annual IoT and data 2020, an IoT and data benchmarking exercise across cities. And these are some of the findings that we found. The report will come out on the 16th and will be launched at our IoT State of the Nation event then. So interestingly, we did find that IoT is the main driver for cross-vertical data integration for Australian smart cities. It's starting us doing the thinking process about how we go up there because it naturally wants the data to be reused. So that's great. The pilots are multiplying, they're everywhere, but they're missing the underlying infrastructure to scale, to impact, as I mentioned. Good news is that over half smart city councils now have a data strategy, which is how they manage it, with whom, under what circumstances they might share it and with whom. I would say they have a strategy, but not necessarily a way of operationalizing it yet. 16% have sort of matured, or say they've matured to a position where they can broker the data, where they can share the data in a managed way, which sort of means that they've got the bones and in some places quite a sophisticated platform of data that they can manipulate. Remember, this is 16% of the smart cities that say they're smart cities, so the actual percentage in councils is no doubt lower. And the number one blocker for all of this is capability. The blocker to sharing data internally and externally. I'm not going to go into it in any detail right now, but that capability is obviously one to unpick, and it involves a lot of issues. Some of it is around leadership. Some of it is around the ability to mount a business case. Some of it is around the ability to appraise market solutions and the technology itself. That's an internal skill issue there. Some of it's got to do with internal procurement guidelines that prevent these innovative things to be readily procured beyond a pilot. So there's a few issues to unpack in getting there, and yet some are punching through or trying to. and often that happens to coincide with other initiatives such as Smart Places thing that New South Wales government's now doing, and the city deals that the federal government's been driving. And interestingly, just one data point is that 47% say that budget is a barrier to sharing externally, and only 36% say the budget that it's a blocker internally. And considering that the technology is pretty much identical, it's interesting. So budget sounds like a proxy for something else that's a problem as well. So it's this case of perceived ROI, etc. So quite a few things to unpack, quite a journey to undertake. We believe a massive upside for those who take it. We have many use cases of great things happening in many verticals, but it hasn't yet realized itself in the smart city land. And that is my presentation to you all. I really appreciate you listening to me, and I do hope I've not been too confusing, and that you've learnt something. I will put myself back into the picture for those who haven't seen me before.
Wonderful, thank you, Frank. So, audience, this is your chance to ask some questions on that. I can see Peter is typing, so I'll give Peter a chance to hopefully get that question out. Let me kick off. I was really interested in the detail that you've taken through in the maturity levels, and I had two questions off that. I think my first is that with the maturity level 1, I'd be really interested in your thoughts of the importance of getting that really right and scaling that versus trying to move to the next maturity levels. And then my second question, regardless of what your answer is like, if you think about stuff like the New South Wales Spatial Digital Twin, and where we want to go with that, do you think it is okay actually to be forging ahead in pockets at the different maturity levels?
Okay, so no, great questions, Rory, and they're both highly relevant, because when you say maturity, when I say the maturity levels, it looks a bit simplistic. It is simplistic, but it isn't just about the technology. It's also about the learnings and understanding. And so I think phase 1 is necessary to simply learn and understand what it is you don't know. Whether you leap to level 3 or level 2 or whatever, without having gone through some of that pain, unfortunately, we found that the council simply don't know and can't differentiate between what good and bad is. Why you even need a data policy, why some of these things actually mean something. In the absence of that experience, the abstract discussion of data policy or the abstract discussion of federating data sort of just bounces off people's heads. So it's sort of a necessary step in terms of the evolution of understanding. Having said that, this idea of leaping into bits where others are at maybe a different level of maturity is also a great way of understanding. It provides you an insight to say, "Ooh, it could look like this." And I would say that, and because the drivers are different within city councils and within state government, I mean, so there's a different social capital and a different investment portfolio. So the ROI for New South Wales spatial networks is a different one to councils. They can afford to do this. And there's some sort of social ROI contract that's understood that councils can benefit from, that they evidently can't do internally with their own constituency. And so I think that's sort of leveraging another ROI model. So I think surfing that is absolutely a brilliant idea.
All right, great. Look, I think you're right. The lens between state and say local government is obviously different, but that's where we're quite passionate about. How can we actually work together so that we can bring the best of both levels, right? And so obviously from a state perspective, whether it's a platform that has automatic scale for the whole of the state that a local government can be tapping in. But interestingly, what local governments are doing, and how can we then kind of learn and replicate that to others in support of the existing work that's being done by a number of the industry bodies. I do see that there's tandem roles going hand in hand.
Yeah. I mean, just another point, which I didn't really pick out in my presentation, but what most councils are doing today is they're sort of knife and forking it themselves to build these data platforms. So that's not a long-term sustainable model. Eventually, that's got to go into either their IT or it's an outsourced thing. It's got to be one of the two. So that sort of doing it as cheap as possible, that's great for when you're doing it for a pilot. But if you want to rely on it, it's got to get out of OT into IT to some extent. And so that evolution is something that's a long way to go, and it's a learning exercise. And so some of the bigger councils are actually considering building their own teams to be able to constantly do that, or even manage it. And if you're a big enough one, maybe you can do it. For most, it's not an achievable end goal.
Yeah, and maybe just closing off on that, this then is that challenge of, I think, sort of scale of replicability. So, if bigger local government areas can do that, and then there's others that can't, then you're actually sort of exacerbating that digital divide that we see coming up in quite a number of ways. All right, let me go to Peter. Peter's got a couple of questions for you here. He says, often I see prospective customers unwilling to recognize that validating their ROI expectations is a big upfront cost as a supplier with uncertain benefit. And are customers realistic in their expectations of investment by suppliers in pilots? And hopefully, Peter, I've got that right. If I haven't, do feel free just to pop off mute and ask the question directly.
Yeah. Okay. All right. So, I mean, this is right at that crossover that I see between technology provider and user. Both suffer from the problem that neither understands each other really, really well. And when you really do, then I suppose must be a supplier by now. But I find that the councils are sort of frankly testing the technology rather than really honing the business case. For some, there are business cases that work. So the business case around some of the rubbish collection things makes sense. But frankly, a lot of it is sort of rubbery, really. And so I think that understanding the real problem and how operationally you might change if you had the data that would make it better, that's a journey that hasn't yet been done well. I think part of our role in IoT Alliance, and I think Smart City Council and others, is to start getting a library of those use cases that do have ROIs, depending on size or whatever, to make it more evident. And I understand your challenge is that every customer either knows or doesn't know what the ROI is, and their circumstances are different. So yeah, I think enabling through use cases that are commonly understood might be a pathway. I don't have the other answer because this happens in every sector as well as smart cities.
True. No, and just that final, what's OT?
Yeah, look, I really apologize. As soon as it is jargon. So that's called operational technology. And as opposed to IT, let me tell you, IT tends to be the relationship management system, or your billing system, or those asset management platform, or whatever is an ERP system. OT tends to be the technology that helps the workflow of the company. So it's something that tracks where things are going and then directs behavior. Alarms, things that go wrong. So that, and often what tends to happen in companies is that the operational side has its own technology completely to the company that does the billing and invoicing and customer relationships. And so what's tending to happen in this operational technology side is it starts becoming quite important to the actual operation of the company itself and the database that it has. They start overlapping. And so this connecting those two together is part of that future challenge. But for me, when I say operational technology, that always means that's the ROI space. What is the operation that you're trying to improve? And if you get the answer to that question, then IoT becomes real.
Awesome, thank you. All right, look, Frank, thank you so much for taking us through, especially those points on the maturity levels and in different pathways. I do want to remind everybody that next week is the State of the Nation event, and if you want more details about that, go to ithub.com.au. Maybe we'll, Frank, stick in the just stick in the chat a link to that in case anyone's interested. All right, so if we've had a strategic view, we are now moving to IoT in the trenches. What does that mean? All right. Well, for that, we are very grateful to have Professor Pascal Perez. As I mentioned, he's the director of the Smart Infrastructure Facility at the University of Wollongong. And there he's overseeing research into infrastructure-related fields such as water and energy efficiency, future transport and mobility, smart cities and communities, as well as infrastructure systems engineering and logistics. He's a specialist of integrative infrastructure modeling and socio-technological transitions, and a fellow of the Modeling and Simulation Society of Australia and New Zealand, and a fellow of the Royal Society of New South Wales, member of the Executive Council of IoT Australia Alliance, and a member of the International Advisory Board of UK's Collaboratorium for Research on Infrastructure and Cities, and contributes to the Standards Australia's technical committees. You gave me a challenge there, Pascal. You are doing so much in this space. So again, I'm delighted to hand this session over to you and look forward to hearing about the experiences of IoT in the trenches. Thank you.
Thank you, Rory. Hello, everyone. I'm really grateful to the organizers, so Australian Computer Society and New South Wales EPI for organizing this session. I'll try to share my screen. Yesterday the rehearsal didn't go that well, but this time I hope it's going to be okay. So let's try that. Can you see my screen?
Not yet.
Not yet?
Not yet.
Oh my God. Now?
Sorry, Pascal.
Gosh, okay. Let's check in here. Share entire screen.
Oh, this looks good.
Mark, do you have a copy of my slides?
Yeah, bear with me one moment. Let me just bring it up. If you'd like to just...
it's my dual screen that's playing on me again, sorry about that.
Yeah. If you'd like to do your presentation, it's just going to take me a moment just to bring it up on the screen. So I'll be there shortly.
Okay. I'm going to try again. Oh gosh. Sorry about that, everyone.
Bear with us, folks. I think we're at maturity level 1 for our teams.
I hate Teams, sorry, I have to admit. I've got 2 minutes left.
Pascal, I'm just uploading the slide deck, which I need to do for this. Yeah. Do you want to just start your presentation and I'll catch up?
Yes, okay. So just as mentioned by Rory, I think Frank gave us a vision from a strategic point of view, so vision from the headquarters. After me, Kim will give you, so it's the world as it could be. After me, Kim will probably present you a world that it should be, the world of smart cities and IoT from a standard perspective, if all the standards were applied and in place. So what I'm going to give you is the in-between, is the world as it is now, a view of the trenches, not from the headquarters. And in his key findings from this survey that Frank mentioned, he touched upon a lot of the points that I'm going to make. So I think we all dream of a smart city as this glittering, modern, shiny, glass-covered city that you can, for which you can have all information at your fingertip on your laptop, on your tablet, or even on your iPhone. If you could see the slide I was going to share with you, I would say that at this point in time, and back to the levels that Frank shared with you, most of the cases have been across so far are muddying into level 1, and it's more like an entangled mess of wires, like the good old Indian cities where you've got wires everywhere, rather than a brand new shiny city. And why am I saying that is, oh, that's everything. Everybody can see that?
Yes.
Oh gosh, we're very good together. So that's the way I see it. Now, why do I say that? Well, it's based on two things that probably some people on this call have heard me before banging the table for years now about a couple of issues that I think we haven't resolved yet. And again, Frank touched upon some of them, but also from experience we've acquired at the Smart Infrastructure Facility, helping many councils with their especially smart city and suburb projects funded by the federal government, round 1 or round 2. And unfortunately, I think all these projects are more or less at the same kind of again, level 1, maybe level 2, but not much more. So next slide, please. So the first issue that's for me is at the heart of everything is what I call social disconnection. Next slide. And by this, I mean that if what a smart city and IoT is a revolution, it has to start with people and end with people. What we have so far is something that starts with technology and unfortunately too often ends with technology. That's what I tend to call a technology epidemic, not an evolution. We've all heard about the ethical AI, about even the price of privacy. Will we have one day to pay not to have our data stored by somebody else somewhere else? And here I'd like to point at two documents. Can you click, please, Mark? So two documents that everybody should read at least once. The one on the right-hand side is a very recent report from the Australian Human Rights Commission about human rights and technology, and there's a large sections about smart cities and IoT as part of smart cities. The second document on the left is a bit, it's not that's shiny, but it's a very important one. It's a draft report from the UNESCO about ethical AI. And again, there's a lot of privacy aspects there. But more importantly, something that we should all be aware of when we talk about smart cities and these algorithms we put behind the IoT sensors in order to create what we call AIoT, so artificial intelligence of things. These algorithms are too often, up until now, created by young white males. And we all have to be conscious about the fact that this is creating potentially a massive bias. So just to summarize here, the issue is that we all have to accept the fact that smart city is a sum of many parts that have to work in the same direction. It's about people, it's about infrastructure, yes, but it's also about governance. And that's where standards, of course, come into play. So what I think there's a call into arms for literally a social license to operate for smart cities as I speak. And I hope that the New South Wales Smart Places program will really, really at the forefront of this new engagement for smart cities. Next slide, please. We know how to do that. We know how to do it. We know how to bring people on board. We don't have to invent anything. It's already there. We've got at least 50 years of community engagement, practice, theory, methods, tools. And this is an example from a couple of years ago already. We implemented with Liverpool City Council with a round 1 smart city and suburb grant about smart cameras in the city of Liverpool. And what can go wrong when you're going to tell people, oh, we've installed a couple of smart cameras to look at you in the CBD? Well, we did the reverse. From day one, we said, okay, let's sit down with people from the community and different organizations and try to understand first what are the problems in the CBD of Liverpool they're facing from different domains, transport and others. Also, what are the kind of technology that could help to solve these problems? And as we play, and it was a game called Arkinopoly, we developed with our colleagues from Arki Lab in Copenhagen and in Sydney now. We took the advantage of this workshop, having people there to explain what the technology was about, showing a camera, explaining what an edge computer is, explaining that the frames of the pictures were not going into anybody's computer. And then at the end of the workshop, the people all around the table were the one telling us, oh, you have to put the cameras here and here and here. When you reach that point, you know you might have a more successful project than if you don't do this from day one. So we know how to do it. It's just we have to be used to do it all the time. Next slide, please. The second issue, and that's really my number two, but in order, in picking order. It's the lack of interoperability of what we put in place for the moment, especially in Australia. Next slide, please. Again, this slide is a bit old. It's probably three years old at least. It's still valid. So you've got stacks based on NB-IoT, so a cellular-based technology, or Sigfox, or LoRaWAN, which are two non-cellular-based LP1 solutions. As long as one client deals with one vendor or integrator in order to deploy sensors and gateways and the cloud solution or the backend application on server, it all goes fine. And that's, well, as long as everything is of good quality and being implemented the right way. The issue is that, and this is not a ridiculous idea, imagining one council was invested at year one into an NB-IoT solution, for example, for one application, and once 3 or 4 or 5 years later, because people have moved on and there's more money, to implement a Sigfox or LoRaWAN-based solution. There's no way this solution will talk to each other. Another extreme case is the fact that maybe one of these technologies will be obsolete in a couple of years. You won't be able, for the moment, to transfer the sensors or even to transfer the data from one to the other. The only way you can do that is if you have a perfect knowledge of the whole system from day one. And this is a major issue. Next slide, please. What frustrates me, and that's why it's in top of my list, is the fact that we know how to do it. We know, and Frank knows that, and IoT Alliance Australia has been working very hard to literally preach around the best practice. So that's what we call at Smart Infrastructure Facility the agnosticity architecture, where in different cases, in different projects, we've installed different type of sensors or cameras or temperature or wind or whatever. And we have different connectivity rather than transport, sorry, wrong term here, whether it's Wi-Fi, whether it's Ethernet, whether it's Bluetooth, whether it's LoRaWAN. And then we bring all these MQTT brokers into one cloud most of the time or server-based solution. And then we can develop applications that can bring all this data together in a proper data fusion process. For the moment, what we're doing through the MQTT protocol is it works very well from the sensor to the gateway or to the hotspot for Wi-Fi, but we don't have an end-to-end totally homogeneous solution. The frustration comes from the fact that there is a standard that is in the making, because it's very hard to put together. It's called 1M2M. It's being pushed and pulled by ETSI, one of the 5 big bodies for telcos around the world under the International Telecom Union. So there's a standard in the making, and when we've got this standard end-to-end, then finally we're going to have this interoperability. But it's still a long way to go, but we have to contribute to it. We can't expect anybody else to do it if we don't contribute as an industry in Australia. Next slide, please. My third issue, leveraging legacy assets. So here I retake the use case of councils who are rushing because of the kind of programs they were funded through, literally going to the supermarket, buying all the widgets and gadgets they could buy, and putting as many of them in the neighborhood. And the winner is the one who has as many gadgets as possible. Next slide, please. This has two issues. First, most of the time you might have bought things you don't even need, and I'll come back to it in the next issue. But most importantly, you might have had assets at level of the council you could have reused, because a sensor is a sensor. It's not because you call it smart that the temperature sensor is much different than the sensors we were building 20 years ago. It's still the same. A water level sensor is an ultrasonic sensor that I've been using when I was in Indonesia, again, 15 years ago. More costly, and this is a use case we've been working on with many councils now, is the CCTV networks. I've got a grudge against them. I declare my bias here. These are things that councils have to invest into most of the time with a big nudge from the police force. And these poor councils have to pay the cost, the capex and the opex, and nearly only for a use where the bad guy is in the frame and the police is in the room. So we're using ballpark figures, probably 2 or 5% of the information that these cameras are grabbing, and just for security purposes. When you calculate that, and I think these figures are still valid, a camera, if you have to start a network from scratch, so digging and trenching and everything, costs you nearly $20,000 per camera. And then your OPEX will cost you $5,000 per camera, including the man in the room who has to look at all these things, like in the vignette. This is a massive investment for only a harvesting of 2 to 5% of the potential. So next slide. What we've been doing with our colleagues in the university is to develop first a platform that in principle could harvest any kind of data from any kind of camera with an edge computer or not, in order to feed into artificial intelligence algorithms that could be developed and trained on specific use cases. And in the future, think about 5G being deployed in a couple of years. We could even flash these edge computers attached to the CCTV networks directly from a lab or from a council room. It means that each network could be used for an infinite number of use cases without replacing the hardware. Is this science fiction? Next slide. No, it's not. This is what we've done in Liverpool over the last, it's been in place over the last 3 years. So we've got a system where we retrofitted 20 CCTV cameras. So we haven't changed them. We took them as they were. And we just put a server of edge computers in the control room of the council. And now these cameras are used to track traffic, trajectories, pedestrians, and as you can see, you can't see no one, because the only information that's provided to the server are just trajectories of different type of objects or buildings. This technology has been deployed in buildings as well, like our smart infrastructure building here at Wollongong. And this is how you can literally free 95% of the information that you've paid for. Next slide, please. Fourth issue, system integration. And thanks, Frank, because I think that the 4 levels is a perfect framework for me to go through this problem. So next slide, please. This is the view from the trenches. So on one side, you've got sensors that have been deployed in many councils around the country. And these sensors, they don't provide you any information. They provide you data. Then this data has to be transformed into information through servers or cloud-based data brokering, and then your backend application on a computer. And this is where going from blue, the data, to black information. This is something we know we can do very well, and there's a lot of integrators out there and universities, and the whole market is all after this bridge between data and information. Where I think, back to Frank's point, level 3 and level 4, we fall short and we even fall behind, is transforming information into actionable knowledge. And this is where your increased value is. If you look from left to right. And as long as we can't bring councils to a level of value where it makes sense, we're still talking about an epidemic and not a revolution. Next slide, please. And I'll give you an example. I'm not saying it's a perfect example of integration and going from data to action, but we're getting into it, and hopefully next year I'll show you something which is really fully operational. So at what's called the Smart Water Waste Management Project, which has been funded through the Smart City and Suburb grant, round 2, for the 4 councils in the Yawa region, Wollongong, Shell Harbour, Kayama, and Shoalhaven, plus Langlis as a partner, and of course the University of Wollongong. For the ones who don't know very much about Wollongong, we had 3 extreme floods and nearly 30 serious floods over the last 50 years in Wollongong, and a couple of casualties, unfortunately. So early warning system and mitigation strategies have always been at the forefront of the thinking and the investment of council. So when we decided to put an application, they were very excited. Click, please, Mark. Thank you. So what we've done first is that the university itself had invested into a network of LoRaWAN gateways because it was cheap and because this was a protocol we could tinker with and play with as researchers. And the project helped us to move from 6 gateways to 10 gateways across the whole region. Click, please. And as part of this big project, I'll just pick 3 components which are relevant to this talk today. There's a go flow component, and when we ask council what are the problems you are facing, they say, well, in terms of flooding, there's 3 key issues, especially in Wollongong. The first one is the fact that the lagoons and estuaries and coastal lakes, they tend to close randomly depending on tides and depending on the movement of the sand berm that separates the water body from the coastline. And we need to understand better how this happens, because this is crucial to avoid very, very critical flooding upstream the sand berm when we've got a massive rainfall event. So what we did is to create a system using LiDAR technology that looks at the sand berm of one creek. In this case, it's the Ferry Lagoon, north of Wollongong, for the one in Wollongong. And this 24/7 is observing the sand berm and giving us a cloud point of the shape and the height of the sand berm. On the right-hand side, you've got Stop Block. Stop Block tried to address the second major problem that Wollongong has in terms of flooding and damages, is the fact that flooding and the damages due to flooding are mainly due to culverts being blocked. And this is very, very hard to predict with traditional modeling. And then the response has to be very, very quick, and unfortunately, most of the time it's too late. So what we've put in there is a relatively sophisticated and unique, so far as I know, system where you've got 2 smart water levels, upstream and downstream of culvert, and a smart camera with an edge computer looking at the upstream side of the culvert and try to understand the level of blockage of this culvert and try to predict the level of hydraulic blockage of this culvert, picking the information from the 2 water levels. So it's a relatively sophisticated process because the sensors don't send only information upstream, but the camera itself receive information in order to update its prediction. This is also a relatively unique system where we're using LoRaWAN to transfer the information from the water level sensors, but the camera itself, because of the edge computer, uses 4G telecommunication. So these are the goodies, all the things I've mentioned before. So everybody was excited. The researchers, my team, are very excited having done all that. But where is the integration of all that? So next, please. Well, that's it. That's the big monster. So what we have is not only on the right-hand side, we've got the water levels, as I mentioned. We've got also the specific data from the LiDAR and from the smart camera. We also have rain gauges, but not many of them. But what we've done, and back to integration, so level 3, if I'm correct, Frank, we are now able to swallow in real time what's a product from the Bureau of Meteorology called Rainfield 3, which provides every 5 minutes, if you subscribe to the system, the radar reflectance coverage for your area. So we feed this directly into the system. So that's on the left-hand side, the spatial database. And then what's called WBNM in the middle of the little wheel just under. That's the hydrological and hydraulic model that we've developed using the Gamma platform. And all this near real-time data is fed into the model, and the model has one objective and one only, to predict within 5 minutes what's going to happen within the next 10 hours. 2 hours for the moment. And of course, there's a lot of optimization happening. And one day we hope to even recalibrate the model on the fly when we have enough data from all the sensors and the bomb radar. Next, please. How does it work for the moment? And it's not perfect yet. So in terms of integration, so we have these dashboards that give us instant data from all these water level sensors. We've got 20 in the catchment I mentioned. That feeds into the model. So that's a visualization of the model, and it's needed the speed at which the model runs. The top tiles are the bomb reflectance values, and the blue colors that goes onto the catchment are the water storage on each subcatchment. And this, importantly, back to my information to action, is fed into the consequence modeling that the Council of Wollongong is already running in order to send their teams on the ground to save people, to save assets, or even to unblock a culvert. This is still, don't get me wrong, this is not entirely operational yet. We're getting there. It's going to take us another year probably to get everything right, and especially making sure the data is the right one at the right moment. And we've got fallback solutions if sensors start tripping over. Next, please. Issue 5, sustainable IoT, and that's my last issue from the trenches. Next, please. Before I start with that slide, I'd like to make a comment about, and I hope that the survey that IoT Alliance Australia has commissioned will provide us a lot of information about literally, and I'm not joking here, the despair of some councils after the round 1 and round 2 smart city and suburb projects, where they're left with an heterogeneous set of sensors using different protocols. Some of these sensors, including some, we have smart infrastructure facility installed in some councils without clear SLAs, without clear maintenance programs, without knowing even at council whether anybody will be able to maintain them. So what we've created so far is some kind of monster, and we have to fix it. And I saw that Luc Musgrave was on the call. This is a plea that New South Wales Smart Places program will really look at these issues and probably fund some projects in order to look at these issues, because they're really salient problems now. And just to finish my presentation, I'd like to mention the fact that we're creating potentially the biggest problem we've ever had in the world. 100 billion sources of electronic waste by 2030, and we have no idea at all how we're going to recycle them economically. Next. That's it for me. My key message back to everyone is the fact that IoT for smart cities is not the solution. It's a means to the solution. It's a yellow brick road to the shiny city. We all know, because we all know the story, that the people themselves with their specific problems find the solutions using the yellow brick road and going to the shiny city of the Wizard of Oz. Thank you very much.
Awesome, Pascal. Thank you. I'm going to call out for questions. Luc, don't make me pick on you. But I have a question, first of all. Pascal, when you're going through the 5 points around interoperability, social license, so forth, I was just interested in if you could talk to us a little bit more about the differences between interoperability and integration, because you sort of on a simplistic view, you could sort of see this as quite linked. It would be great to just sort of get a clearer view of how you see those being different.
Can you see me now? Yeah. Good point. So interoperability, I put it, and it's interesting discussion I had with colleagues. Where do you start and stop interoperability? For me, I use interoperability in a relatively narrow sense where it's really at the technical level. So the sensors and the protocols and the standards we're going to need for all these sensors, whichever they are, whichever manufacturer, whichever protocol they use, whichever cloud solution they use, they can speak to each other and they're discoverable. So that's the interoperability aspect. The integration is really in the sense, I think Frank described it, with these 4 levels of maturity, where the holy grail for all of us with IoT contributing to smart solutions for smart cities is really on the actionable knowledge, where you're going to have to integrate different types of data and knowledge, and they don't have to be smart. It can be even people contributing to the system as second order checking of what's happening. So that's where I make the difference. Interoperability is really at the technical level. Integration is integration of information and knowledge.
Great, thank you. And look, apologies, I'm just going to monopolize here a little bit. The other thing I was interested in is, and when I saw this yesterday when we got together about that 100 billion sources of waste, I also wanted to ask if this was also 100 billion sources of cyber risk or threat, as you know, we just start to put a plethora of devices and so forth into place.
Yes, the answer is yes, and again, that's where standards come in, and probably the industry itself being at the forefront of the next black swans that will come, because they will come. We've had many demonstrations of even the silliest small sensors being able to be tapped in to access the backend solutions and the backend servers. So these can happen, yes.
Yep.
Encryption exists, so most of the LoRaWAN protocols I know about, they all have their own level of encryption. Encryption is as good as the hacker you're going to face. That's as simple as that. Now, what we have to look at is some kind of analogy with blockchain here. Blockchain can be attacked. It just requires such a massive amount of energy and resources that nobody's trying for the moment. I think the same might happen with smart cities, where if you've got so many sensors everywhere and you're a hacker, where are you going to start, honestly? And what for? You're going to hack the temperature sensors that are everywhere? So yes, the risk is there. Yes, it will happen. Will it be that damaging as we think? Well, of course, there's the ransomware, for the pipeline in Alaska. That's a pretty big example for the moment. But yeah. So yes, unfortunately, but we have to be ready for it.
Yep. Yeah. I'm looking at. I think your point about standards there, and we'll be coming on to that shortly. Sorry, Frank, did you have something you wanted to add?
Yeah, I mean, on that security one, which is a subject close to my own heart. There's one thing is, I think Pascal hinted at it. Yes, there's 100 billion threats, but they're not all the same level threat, and so Paretoing the threat levels accordingly is part of the challenge. So understanding that is really, really, really important. And the other thing is we need to actually make sure that there's a minimum standard whereby we can eliminate most of the, let's say hacking vexatious stuff, right? I mean, we're not going to start protecting against state players, really. That's another order of magnitude thing for critical services, but we need to raise the floor of standards, which is the security by design thing, which is something that frankly is not yet part of the culture and ethos of IoT device developers, and we need to make it really important. So that's something we need to work on.
May I just throw a metaphor I've just come up with, and happy to run with it, Frank. it's the liquor shop thing. Everybody's been in a liquor shop. We know there's a CCTV camera, which is a basic thing to make sure that people don't steal average priced bottles of wine or beer. Then you've got your section and the key where you've got your whiskies and things, and then you've got the very, very special bottles behind the counter. This is what we need to achieve with the smart cities.
Yep.
Yeah, no, thank you for that. And look, one final question before we go on to our last session for this afternoon. And Luke, thank you for adding this. Luke wanted to know if just some insights into the maturity levels of councils and what's needed to motivate upskill councils to get more involved.
It's probably back to Frank probably on this one, but as I mentioned, I think we're dealing with eight councils in total. Whether they've got a high level of understanding or a relatively low level of understanding, so an entry level, they're all facing problems. That's my from a very small sample of council we're working with. That's the thing, and they're all looking for solutions for the future.
Yeah, and if I could throw my 2 cents in there, I think that there are a very small number of councils that are trying to build their own skills base, like actually have employed people who can do this. Some of them have got 2 or 3. That's about as big as it gets, by the way. They are almost none of them ever connected into IT. So whatever the practices and things that for IT, which have been withstood the test of time, but are often considered to be way more too onerous on the OT side. On the that there's no matching of those skills right now, and that's a fundamental problem. So you've got a whole lot of resource maintaining old systems. Those same people ought to be retrainable to do both, frankly. But it needs a mind shift in culture because one does not understand the other. So I think that the people have the capability to have the skills, but they don't have the responsibility to take on the skills.
Yeah, no, I understand. Yeah, indeed. Well, look, thank you for that, Pascal. We're going to move on to our final session for today. We've got Kim Yan, who's going to be talking about IoT and the standards. And Kim, I want to check that you're okay there. It's looking a little bit dark, and hopefully that doesn't slow you down. Kim chairs the Australian Standards Committee, as mentioned, IoT 042 in an area related to technologies, including Internet of Things and Digital Twin. That's a mirror committee of the joint ISO and IEC Information Technology Standard Committees, which deal with complex and evolving ecosystems of technologies and standard development, employing a systems approach for standard development areas, sensors, networks to IoT systems. He's also a member of a number of Australian standard committees, and if that doesn't keep him busy enough, he's also the senior products compliance engineer at Cisco Systems, who are a world leader in networking security for internet, including end-to-end IoT architecture. So again, it's my privilege to welcome Kim, and pleased to hand over to you to hear about IoT in the standards landscape. Thank you.
Thanks, Rory. May I ask whether you can hear me here?
We can.
Okay, great. Because I could not, the headset do not have any feedback, so I do not know whether I can have the clear audio sending through. It's my pleasure to present the standard landscape or standard development related to IoT. Actually, IoT technology have been deployed in various application domains. A large number of standard development organizations and consortia are involved in developing of standards for IoT technologies. These, just name a few, these include ISO, IEC, ICCC, SC, Standard Australia, etc. And this afternoon, I would like to talk more about the international standard organization ISO and IEC. They have a joint technical committee called JTC1. Under the JTC1, there is a subcommittee called SC41. SC41 is mainly a strategy committee manage different working groups. Is mainly working on IoT and digital twin area. There are about 5 different working groups, starting from working group 3. Working group 1 and 2 were disbanded, and working group 3 mainly working on IoT foundational standards. They undertakes standardization activities for reference architecture, frameworks, and vocabularies. And they also establish and maintain a flexible base of platforms and aspects from a wide range of vertical markets are considered as well. And this working group will cooperate with ICT experts and vertical domains experts. And the second working group is working group 4, which is sorry, I don't know why. Working group 4. The working group 4 is working on developing standards about interoperability and other topics such as underwater acoustic sensors, networks, and web-oriented architecture system model for interoperability. Working group 4 will also develop standards for testing, such as IoT interoperability tests and IoT conformance tests. The third committee is Working Group 5. Working Group 5 main work standardization in the area of IoT applications, use cases, IoT platform, middleware, tools, and implementation guidance. Working Group 5 activities are mainly for IoT use cases, IoT platform, middlewares, and implementation of guidance, promoting interrelationships among various application domains, adapting and expanding the scope of Working Group 3 and Working Group 4. The other working group is Working Group 6. The title of it is Digital Train. This working group mainly develop documents or standards related to digital train or IoT and digital train related technologies. Working Group 7 is a newly established, is establishing working group because of there is demand on maritime IoT and underwater IoT. That's why SC41 established this new working group, WG7. It's mainly responsible for develop maritime, underwater, and inland waterways things, digital train, and related technology standards. And this working group will cooperate with other standard development organizations such as ISO, TCH, IEC TC18, the Center for Maritime Research and Experience Center, and ITUR WP5B, and also IALA, International Association of Marine Aims to Navigation and Lighthouse Authorities. And other than those working groups, JTC1 or SC41, also our member of IEC subcommittees, such as System Subcommittee on Electrochemical Aspect of Smart City, System Committees on Smart Manufacturing, System Committee on Communication Technologies and Architectures, System Committees on Active Assisted Living. And other joint working group C, which is a joint working group with the IEC System Committee Smart Energy. And this working group is calling for experts to contribute on the development work related to sensor network and its interfaces for smart grid systems. And maybe I introduce the current work items that happened in SC41. These include IoT architecture and framework, and also vocabularies documents. And the other one is IoT interoperability, connectivity, IoT platform, middleware, conformance, and testing. I'm not sure you guys would interest in the description of those documents. You will find they are mainly the title of the IoT, like this one, IoT monitoring system for exposed dangerous chemicals. And this is a new project, and there were different opinions about this project in Australia. Somebody claiming they are experts in exposed dangerous chemicals do not actually agree to have this new project, and others do not have any opinion on that. But anyway, internationally, the committee believe is a worthwhile project need to go ahead. That's why they are now in the NP ballot stage. The other documents, such as generic trust anchor API for industrial IoT devices, synthetic interoperability, and there's one very interesting thing is underwater network management system interworking document. This is in the final draft stage. Another group of documents that are working on is the IoT application use cases, tools, and implementation guidance. There's a DLT blockchain use case, and also underwater acoustic sensor network. Another one is underwater wireless acoustic network, electronic labeling system, and also compatibility requirements and model for device within industrial IoT systems. Underwater communication technology for IoT. This is published currently, will be published soon. And the other set of document is digital twin documents. They are working on use cases and concepts and terminologies. There are two new projects, which is guidance for IoT and digital twin use cases. Another one is reference architecture. Maybe I just introduce a few new work items within SC41. The first one is resource interoperability among heterogeneous IoT platforms. And this document will provide a resource interoperability framework for interworking between heterogeneous IoT platforms. The resources in this document refers to surveys, including device IDs that's supported by diverse IoT platforms. The proposed interoperability framework concentrates on converting resource path in a specific IoT platform to the target IoT platform. The resource path, for example, the URI, the Uniform Resource Identifier used in the heterogeneous IoT platform. Another new project is interworking between heterogeneous underwater networks based on underwater delay and disruption tolerant network, UDTN. As you can see, this project will talk about two types of gateway. One is the surface UWA underwater acoustic and also disruption tolerant network gateway. Another one is the mobile gateway, which would be underwater. The mobile gateway will work together with the other looks or other networks underwater. So this document mainly for this type of network. It will provide the network surface for different underwater networks. Another document is about access and management requirement for IoT devices. Current standards for IoT device access, no matter you use or you base on UPnP protocol or portal authentications or device networking, and these cannot prevent the problem of private connections or unsolicited connection of IoT device. The main security threat we know that is illegal connection or personal connection, device offline, and device management. The access and management entity in this is to control the access of IoT device. It will include four parts. The first part is device management, and then device access. The third part is access policy manager and the log audit. The other new project is the functional requirement related to status of self-quarantine through IoT data interface. And this project was initiated by a Korean expert. And this is because recently in Korea, there were a lot of COVID cases, and they want to utilize the IoT infrastructure to check the status of those in quarantine, and using mobile apps or management systems. And those under quarantine may have a optional wristband, and such that they can detect the status of those guys. And this is a standard specifically developed for that purpose. Digital twin reference architecture is the new project, and this is a very simplified view of digital twin reference architecture, from conceptual model to reference model and architecture view. And in fact, reference architecture could be viewed in different ways. Is use view, a functional view, implementation view, and deployment view. So this could be further developed, but I don't want to waste the time in here to explain how these fields could be expanded. There's another project, is the second edition of the IoT reference architecture. In here, we introduce a trustworthiness point of interoperability, and this is very important, as you can hear from the previous two experts. Securities and trustworthiness is play very important role in IoT. Maybe let me talk about a little bit of trustworthiness. Trustworthiness is based on assurance, and also based on characteristics. And we have trustworthiness, and we also have trust. Trust is based on the behavior, and then trust could be measured, the confidence of the trust, and trustworthiness is based on characteristics, and we can see characteristics would have different domains, such as safety, security, privacy, resilience, reliability, and governability. I've seen a very simple example talking about explaining about trustworthiness, and that is, for example, a UK doctor, oncology doctor. He would be the expert in diagnostic of cancer, but he may not be an expert, or may not be trustable for fixing a car, and he may not be trustable to work on other country. Because of that, we know that they are talking about trustworthiness. You're talking about scope and also expertise areas. Simplified trustworthiness view is talking about a system. Say, for example, this is system A. It will operate by the owner of system A, and then it provides the evidence of assurance. So this would create the trustworthiness. In fact, it's also talking about the whole ecosystems. Because of timing, I really don't want to spend that much on this area. I'm coming back to Australia. In Australia, we have a committee called IT 42. IT 42 is a mirror committee of the ISO IEC JTC1 SC 42, and also working on Internet of Things and related technologies. Currently, as IT 42 already published 8 different documents. The first one is the IoT application of sensor network for wireless gas meters. And I have to explain the destination of these documents. Will have ISO IEC. That means this document, in fact, adoption of the ISO IEC standards. The second document is IoT use cases. The third one is the reference architecture, and then interoperability for Internet of Things systems. And this is the part one. The part one is called a framework. It's about related to framework. And other document is IoT vocabulary. And one thing I want to say is I do not know Standard Australia would like me to discuss this is this vocabulary. You may be able to find it without actually purchasing the standard. It's in IEC had a page which would list all this vocabulary. And another document is interoperability for IoT system, part 2, transport interoperability. And the other document is industrial IoT, and the other document is edge computing, IoT edge computing. And I would like to stop and here and want to see any questions from audience.
Thank you so much, Kim. Extremely comprehensive, and for the audience, the good news is that we will be sharing slides after this so that you'll be able to access that detail. I have asked for questions. Maybe just a really quick one before we sort of move into more open discussion in the remaining time, is that there's obviously a huge amount of detail here in the standards. What's the best way for somebody to start accessing these for the work that they might be doing?
I believe you asked if somebody wanting to contribute in the development of these standards. In Australia, the Standard Australia, there's a committee called IT 42, which is the strategic committee, which mainly provides strategic direction to the working groups, like say, for example, under this IT42, there's a subcommittee which is specialized in digital twin. So that subcommittee consists of experts, and experts don't have to be nominated by organizations such as IoTA and other organizations such as Engineers Australia. That means anybody who wants to contribute on standard development work, they could participate in those subcommittees. With regarding to the international standard, then it must be nominated by the national body. In Australia, the national body is Standard Australia. So if anybody wants to contribute into international standard area, they should be a member of these subcommittees. And from there, they will be nominated, or they can nominate themselves and get the main committee, like IT42, to endorse their nomination to the international committee.
Yeah. Okay. All right. Thank you for that. Well, look, everybody, we only have 10 minutes left, and some of us may also be sitting in the dark like him. But I do want to open it up to sort of conversation. Frank, I appreciate you put your hand up. So away you go.
Okay, I got one question and one observation. But firstly, on the trustworthiness thing, is the intent that the different components of an end-to-end IoT chain add their trustworthiness together to work out whether you've got a weak point in trustworthiness?
Yeah. In fact, you talk about the end-to-end system. There are different trustworthiness points. That picture, I'm just showing that in the whole system, there is a requirement to build trustworthiness. If we actually look at the reference architecture, the data addition, you will find that there are different points of trustworthiness.
Yep. Okay. Sounds to me like it's going to take a long time.
Yes, it's still in a project proposal stage. So right. You, as a member of IT42, you will see how they developed.
Yeah. No, thank you.
Or you, I will say that you probably would be nominated to one of those working groups to develop those sort of standards.
Right. Looking forward to it, Kim. The other comment I make, I think, Rory, in regards to your question about how you use it as opposed to how do you contribute to it, you have to buy a standard. That's a bit of a barrier because in some ways, like there's no way a city council is going to buy 20 or 30 or 40 or 50 standards just on the off chance they could use them. So there's a necessity for entities to translate those standards into understandable stuff anyway, because I mean your average council person is not going to be able to understand the standard anyway, probably. So there's a translational job. The standards provide the foundation and the common platform, but there's that translation function. Well, I think IoT Alliance is part of that job, but I think there's others, consultants and universities and everyone else have to translate it because it's a little arcane and sometimes, unfortunately.
Yeah, I'd agree, and thanks, Frank, for kind of picking up, because I think that's probably my biggest reflection. For those that are in it day to day, then for sure this might all seem straightforward, but for those that are even just sort of 1 degree outside, it is going to be very complex and difficult to access. But if I reflect on what I've been hearing from you, what I've been hearing from Pascal, there's points about interoperability, consistency, wanting to move away from, I think, the cost and time of, say, data cleaning or data manipulation, if we want to move up those maturity levels. This feels like something is going to be incredibly important for us to get right. So that translation from the actual technical to the implementation piece seems like there's a bit of work to be done. It's something I'd be keen to potentially explore and chat to you separately about.
If I just make a comment back to the trenches, as you mentioned kindly at the start, I was actually the representative of IoT Alliance into IT 268 Standard Australia's subcommittee for smart communities. And a couple of reflections. First, Kim, just hands down, your knowledge and understanding of the jungle of committees and subcommittees, national level, international level, is just extraordinary. I think no one in this call, except the ones who have been into it for 10 years, can understand the level of dedication it requires. Because honestly, I raise my hand and say, yeah, I want to do it because it's fantastic. This is the most frustrating process, honestly, I've ever been through. You've got these ballots thrown at you all the time. You don't have time to read the documents, and you have to contribute. And at the same time, you cannot report back to the institution, in this case, IoT Alliance Australia, who nominated you as a representative. For me, it was a very, very frustrated exercise. And honestly, I'm really amazed by the people who have been there, like you, Kim, I'm sure, for many years, pushing and pulling this massive monster. But at the same time, we need it. The second reflection, back to the trenches, is the fact that I feel like because this process is so slow in many regards, it's like the hare and the turtle race, where things happening on the ground happening so fast that the standards cannot catch up, and that's my main worry for the moment. Sorry, just two reflections from the trenches.
I can agree with you, Pascal. Honestly, you heard me say that SC41 already developed 20 documents. IT42 only adopted 8 documents. You can see the big gaps in here. We lack of experts to actually review those documents and develop the project proposal to Standard Australia to adopt those documents or modify adoption. With regarding to international committees, I can see that it's very difficult to actually contribute because you need to go through the formality within Standard Australia. And then once you nominate to the working group, there's a pile of documents you need to go through and understand the philosophy of how they come up with this proposal. And what you want to do, you may not be aligned with other experts. Then you need to consider to prepare expert contributions. They have their own formality. You have to fill in those different forms, and depends on whether you can convince them to accept your opinions or your contributions. I can appreciate your frustration, but we still have to do it. We still have to dig into those bureaucracy.
Thank you. Well, look, we are approaching the end. There's only a couple of minutes left. So I want to say a big thank you to Frank, Pascal, and Kim, both for their time in preparing for this afternoon and giving us some fabulous insights into IoT for smart places, smart cities. Thank you for that. I'm also really pleased to say that the presentation materials are available from this afternoon, and Mark's actually dropped the details on that into the chat, so you'll be able to pick it up. And the recordings for today's sessions are going to be made available in a few days on the ACS Technical YouTube channel. Two more things from me before we close off. Masterclass number 10 is happening next week, and that's going to be all around investing in smart places. We've got Michael Komenos, Jason D'Souza, and Meredith Hodgman, who will be the panel for that session. Now, it's actually going to be on the Tuesday, the 15th of June, same time, 4 p.m. to 6 p.m. So if you haven't registered for that, for those that are listening to this conversation, please do so. With that, I'm going to draw close to today's proceedings. Thanks for those that have managed to stay through the full session, and I wish everyone a very good evening.
Thank you, Rory.
Thank you.
Pascal.
Everyone. Bye-bye.
Bye-bye.
Thank you, everybody.
Thanks, Christine and Peter.
Bye. Have a good day. Bye.